Without further ado, I'd like to introduce Peter, who is the mobile platform architect here at Capital One. Peter is a technologist at heart with a passion for mobile and artificial intelligence. As a mobile platform architect, he helps accelerate delivery times by creating cross-functional solutions to problems that impact multiple domains. As founder and co-organizer of the GDG Wilmington and one of the GDG Regional Leads, Pete helps organize meetups, community mixers, and presents on the latest in Google technologies. So let's hear it for Peter.
Thank you. I'm going to set this up real quick. How are we doing this evening? Well, thank you for coming. Hopefully I don't disappoint. We'll be talking about how Capital One integrated Flutter into an existing app. We're going to go through sort of our journey, how we got there. He mentioned all of this. The only thing that he didn't mention would be if you play video games. I do as well. There's my PSN and gamer tag and my government tag. I love playing video games. I'm not good at them, so don't rely on me for that. But totally hit me up so we can play a couple of games. So moving on. So overview, this is what we're going to talk about. Flutter, what is it, and why use it? And then made these slides and looked at that and I'm like, you guys don't want to hear that. You know why you're here. You know what Flutter is. You know what you're doing. Of course, if you do want to talk about it, free afterwards, feel free to come and talk. We're going to go right into feature selection, how we went about picking a feature to make and rewrite in Flutter. We're going to move on to the production-ready requirements. Some of them, the Capital One has. It's a small subset. It's obviously not all of it. We can't give away everything that we do internally. And then some considerations, things that we ran into, some pitfalls, around development environment, just management of code, assets, things like that. And then, of course, that native integration piece that we talked about and getting Flutter into an already existing app. So our feature selection process. We wanted something that was already in production. We didn't want to pick something new. We didn't want to pull something off our Jira board or from our backlog because Lord knows getting one of those to production takes more than a couple of days. Something that was well defined. So the feature had to already exist. It had to have all of the business logic and the rules behind it, stuff that we could easily reproduce and or leverage, as well as the user experience, the way in which the user reacted, the way in which the system responded. We didn't want to downplay or downgrade an existing experience as well. We needed something that was stable, something that had been in the app for a period of time, that where the APIs weren't constantly changing, something that hadn't been altered in some time potentially. Quick turnaround on the actual experience. So we didn't quite know how long it would take us to learn Flutter, integrate it, build the new feature, and then turn around and add that into our system. And we were given a significantly short amount of time in which to do it. So we wanted to make sure that what we had picked could fit into our timeline. We needed something with leadership support, something that they were willing to allow us to rewrite in Flutter. Not that we wouldn't have done it anyway, but it's a nice thing to make sure that they're behind you. They give you the time, the air cover, the things that you need. And because we're developers, and while it is something that was already defined, we wanted something that was non-trivial, something that had some meat to it. And that's why we ended up with Branch ATM Finder. There were tabs, there was a search box, we had a filter, and the maps component that everyone complains about because it's not quite ready in Flutter, even today, sadly. So we picked our feature. So production-ready requirements. We have requirements around security. I'm going to call out that specifically our obfuscation and cert pinning. We have localization. Our app supports both English and Spanish. Accessibility is a requirement. We are a bank, and we have to follow all of the regulatory standards there. And then, of course, testing. So for security, they do have obfuscation for the dark code that is generated, and as well as for the wrapper, although, as you can see from the little box down here, They basically want you to not obfuscate any of the wrapper code that they've generated. The obfuscate flag will go through and it'll rewrite the dark code that gets compiled so that it is obfuscated but still functional. ProGuard rules get added. You'll notice that this is for Android. Obviously for iOS it's a little different. And so you'll see a little Android guy with an Apple shirt here to tell you that it's iOS, in case you didn't catch that. So the scripting, you have to actually, funny enough, go and update the SDK. I don't know why they don't include it. Maybe they have since I've last seen this. But if you plan on doing obfuscation, you have to add this as an option inside the global Xcode backend shell script, plus the function that detects, integrates, and upgrades. And then, after all that's done, you can then go and add this value, which will then obfuscate in whatever XC config file you place the extra gen snapshot options in. I don't know why this top part isn't already done for us. Maybe someone here can submit a PR and get that in there so that everyone can use it, and we just need to do this last step. But at the end of the day, obfuscation's covered. We can do it. We knew we were good. What about certificate pinning? So there was one option, and that was to use a security context. Security context, you have to have the trusted certs. You would set them all, and then you would hand that to the HTTP client. This is all dark code. Again, Android guy, little Flutter shirt. So you can do this, and we saw this as an option. Our only concern was we'd have to build a second network stack. We already have one. We're eventually going to integrate this into a native app. That's our end goal. We didn't want to waste time building a new network stack in Flutter or Dart. At least not today. Maybe someday we will. But in the meantime, we already had a perfectly good one on our native side. So our second option was to use message channels and reuse our existing stack. So take the data that was coming from the user, add it into the message channel, send it over our existing native network stack, and spit the reply back out to Flutter. And so the code, very similar. We use a basic channel to send the data and handle responses and errors. On Android, in Kotlin, because we're pushing Kotlin today, we have this wonderful set message handler that took that message and processed it. On iOS and Swift, we have this wonderful callback as well. So we were able to take the data and use our existing network stack, which was CertPin, which had all of that information for us. And that actually sped up a lot of time. It actually led us to an area where you could build more and do more with the branch ATM Finder. Localization. So as I mentioned, Capital One supports both English and Spanish. And Flutter supports localization using the Flutter localization dependency. It's part of the SDK. And you need this regardless of how you decide to implement localization. I'll get into that in a bit more detail shortly. When you add localization, you need to add it at the material app level if you're using a material app or a Cupertino app or a widget app, whatever your root app is. You need to set up a localizations delegates, and you want to add the global ones so that all of the existing widgets within material will actually continue to run. They complained if you didn't add these because the widgets were looking for localization event items and information, and without them they couldn't translate into the language that the user had placed their application or their device in. So adding those is pretty much mandatory if you are doing localization, and then of course listing your supported locales. They take two strings, the language and the country or the region. So it does support regional dialects. English in the US, English in the UK, or just, if you leave the second, the region code blank, it's just English that you support. So as I mentioned, there were two options. The first one was using Dart, INTL, the International Library from Dart, where you would return a message and you would set up the user-facing description. You would set it with a name and give it a description for the scripts to generate, and then you would go through and you'd write the AP files, and then you'd have to go back and Dart INTL was interesting because it was a heavy process, and we weren't, again, looking to do something too heavy. We decided a simple map was the way that we were going to go with this, and again, this is information that you'll find in the documentation. I apologize, my color coding's off a little on this, it seems. I wrote these by hand, so you'll notice that we have the language, and then we keep all the key value pairs inside the map, and then we pull these through the same localization models that are built on either side to support the language that the user has selected in their device. This allows us to centralize it. It felt very much like a typical, for those of you who are Android developers in here, who's an Android developer? iOS developer? Oh. I'm so glad you're here, thank you. Long story short, it felt like the resource files, like being able to combine everything and put all of the language strings together in one area, whereas using the Dart INTL, it would be thrown all over the application potentially. You wouldn't know exactly where it was being used at any given time. So we decided that this simple map would work for us for localization, and again, time constraints, new processes, learning the language. We wanted to keep it simple, even though we're doing something non-trivial. I know it sounds kind of odd. So, I don't know why that was there. Localization, we can do it. Moving on to accessibility. There's a semantics widget, because everything in Flutter is a widget. I'm sure everyone here's heard that before. I'm not the first one telling you I don't. Everything's a widget. There's a semantics widget. That widget has a child, and it tells you how to, I should say, it tells the accessibility service how to render that child through accessibility. And so there's an exclude semantics. The exclude basically says, ignore all of the widgets under this branch. There's a merge semantics, which says, everything under this collapses to me, so speak all of the semantics underneath me as though they were tied to me. So you get nothing below you, is basically everything below you is excluded because it's included in your description. Block semantics. So this one tells you that to ignore your parents and only talk about you. So this is like, I know, right? Just to ignore my parents, just talk to me. Don't go to them, they don't know. So in the widget tree, this is basically if you put up a modal window that only partially covers the UI underneath you. And you don't, so as you're navigating around, you don't want your accessibility to actually talk about the search box underneath the modal, because that's irrelevant. So the block semantics does exactly that. It tells the system, I am actually above everything else that you see in the widget tree, please only talk to me. And then of course, each individual widget has some of them have a semantic label that allows you to overwrite the default behavior that those widgets might have. So a text widget by default will speak about the actual text that you placed in it, whereas if you add a semantic label, it creates a semantic object that puts that label as the spoken value, and the child value of that semantic is actually a block. It's actually an exclude semantics call to the actual text that it would normally say. So accessibility worked, and I'm gonna confess something. I'm an old school developer, so I did. There's more to this presentation, but I actually did the testing slide last because it's testing, and you wait until the end to do that, right? So ultimately, this was really the biggest thing. There's like 3 different ways to do testing, apparently. I mean, there's 4, obviously. You can test hundreds of different ways. But test is what you use as a dev dependency when you're trying to do unit testing, basically Dart code. Flutter test is when you're doing widget testing. Component testing is what most other things call it. Flutter being all widgets, your widget testing. And then there's the Flutter driver, which lets you test the integration story end-to-end within the Dart code. And of course, Makito, so you can actually mock everything and not actually make the real calls in the things that you're not actually testing. So when you're building unit tests, you typically want to isolate. You want to leverage as much as you can the disconnection between your dependencies and the code that you wrote. Because if the dependencies are broken, tell them to write tests. So the project structure of a Flutter and or Dart project, you have the project that you've created, you have all of your Dart files in a lib folder, and then you have a test folder, and this is where you'll find your unit tests and your integration tests, again, depending on what you're building. And there's a test driver, and that's, and I messed that one up, I'll back it up. Your test folder includes your unit tests and widget tests. The test driver will include your integration tests, where you have to, you'll notice that you're building an app that you then instrument through. So you have to build your instrumentation version of the app to do a full integration test of your Dart code. And so your test darts will typically look, with the exception of integration, have a simple main function where you either test and run a Dart unit test, or you run test widgets with a widget tester to test out the actual Flutter widgets that you're using and building. And that's testing. So we're back to the consideration. So this is some of the stuff we learned while we were building Branch ATM Finder. I love The Simpsons, so hence the little quote. Don't do what Donnie Don't does. I'm going to tell you what we did. I'm not saying it's the right thing to do. I'm just saying we did it. So take everything I say here as sort of guidelines on what was done, and take with it what you will. So our development environment. One of the big things that we saw, select the proper template. We were all starting on our own, and we're all trying to figure out Flutter. And there's plugin, there's package, there's app, there's module, there's more things. These are the four that I'm going to talk about. So plugin, package, app, and module. Pick the right one. An app, obviously, is an app. There's a difference between plugin and package, and I keep getting the two backwards, even though I have done this a million times, and I look it up each time. I do a Flutter create-h and read it, and I go, is that the one I want? I actually have it in a later slide, which one is which. One is Dart only code, one is Dart plus native SDK information. So your platform code, your iOS or Android, your Swift, your Kotlin, your Objective-C, your, I guess it's Java. Oh my God, I forgot Java. Everyone can still hear me, right? I just noticed I over here. Perfect. Your environment version. So this is a flag in your pub spec. You've probably seen it. It says SDK. You can include Flutter in that tag after 1.19, I believe it was. So make sure you put it in there. Make sure everyone's using the same version of Flutter. If someone says, I can't compile, it's not working, this doesn't work, this stops a lot of that bickering, thankfully. They do recommend, and I'll call this out here, don't carrot it. You can, they say not to. I'm just going to repeat that because, because. Be aware of Git dependencies. You can actually use Git and pull in your packages directly from the Git server, which we did with Google Maps. And then they changed it to use Android X, and we were all, our app doesn't support that yet. So use a ref where possible. So in your pub spec, if you have a dependency on, say, Google Maps Flutter, and you're using Git, make sure you set a reference point. Make it stable. Make it something that's reproducible until you upgrade. You can set it to master. I think that's probably just leaving it blank. But this was a big point of contention because, again, when it moved over to Android X, our app had not yet migrated to using Android X, and it took us a reasonable amount of time, almost, I would say, 2 to 3 hours to migrate to Android X. That was obviously after we had done our Branch ATM Finder initial. So managing and maintaining, this helps to do exactly that. Documenting non-standard build processes. We used JSON serialization, and you have to do a Flutter pub run, blob build runner. It was a lot of fun, and people would have issues because they would try and check out the project fresh, run it, and it would fail. And they didn't read the README. Always read the README on a GitHub. But we're devs. We wait until it fails. I know. And then you write the test. No, wait, no. Then you work. So if you can, script it out. It's always better. Makes it easier. Check out the code and run it, and be it'd be amazing. Doesn't always. Management. So loading assets. Always specify the package. Always, 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 always. It doesn't matter. They tell you if you're doing dependencies and you're inside a package, use a package for that. No, always. Even if you're in the app, use a package. Because you don't know. Flutter and Dart have this really great way of making your app become a package just by being changed in how it's included, which is really nice because the way that we built this was as standalone components that we then reintegrated in the thing above it and then reintegrated above it. Our actual implementation has 2 run apps. It only uses the one from the package that you actually included initially. So always specify the package because your app may never be the root bundle, it may never be the base package. The assets are all referenced by keys. At one point prior to 1.0, there was also an issue or a bug where it would duplicate assets. So if you reference an asset in a package as the straight directory, and then you re-referenced it from another location using the package notation, it put it in the bundle twice. They fixed that. I think they fixed it. I haven't seen it. Business logic components, or blocks. Use them. You can also build providers that will extend inherited widgets so you don't have to make them singletons, and then you can pull them from the context as you're building things and share them around. That's really great, makes it easier, make sure you're using the right one. You can also change the scope based on where you're building it. So you can have a list of accounts and then underneath that, or a list of ATM locations, and underneath that you can have this one ATM using the one that the user had selected, all through a simple provider, inherited widgets and business logic components. Make use of factory constructors. They're really great. They're a lot of fun. They're a great way to obfuscate out some of the design patterns or choices around a class. When you're building a singleton, you don't want them to know that it's really a singleton. Use a factory. They'll never know the difference. Be mindful of stateful widget. This one's huge. State changes cause new widgets to be created and built. This is different than almost anything else. Flutter rebuilds a widget tree. It recreates things. It simply moves the state to new objects. This is different than everything else. It is efficient, but you should be mindful as a widget's being created, that state moves with it. Don't expect create state to be called every time. That was a big problem we found out. Init state's not always called. So we had issues understanding stateful widget, and I think that most people may or may not have that issue. It's typically the way it is, right? May or may not. Most people have an issue understanding when to be stateful versus stateless. Just keep in mind state changes cause new widgets to be created and built, but it doesn't actually cause new states to be created and built. So create state, initial state, those happen once. Take care of animations, extra care of animations. Your animations will continue to run, whether or not they're actually visible on the screen. So all of that work that it's doing in processing to determine the value, to move, if it's in the widget tree, whether or not it's being drawn, it's still taking all those calculations. So make sure that if you're not using it, if it's not visible and it is stateful, you may just want to remove it from the widget tree until you need it again, especially when it comes to animations as opposed to simply changing the visibility. And don't forget your standard good coding practices. Yes, write tests, it's there, it's first. Your unit, your widget or component, your integration. Use part when building plugins. Plugins are your wonderful block components, would be things like this, things that are in Dart that may also need native components. Part allows you to break up these plugins and these libraries so you don't have to write everything in one file. And if you've done a tutorial, most of them are one file. So please don't write all your code in one file. I thought we got away from that. Use part allows you to do just that. Use a source directory, you see the examples. All of the examples on GitHub show this, and I believe the code labs do, but if you're just going in there like, just take the calculator class and add more to it, don't, please don't. So break it up, use logical files and locations, and then reuse. This was huge. We reuse code that exists. They're out there. There's packages site for Flutter and Dart, and code that already exists even within your own company. You probably have ways of doing things. There are ways to get to that native code that you already have, and other code, and then build for reintegration. Obviously, if you're building components and you're breaking it out correctly, the things that you build can be reused. not just by this app or this function, but by other people at your company. Again, when you go to rebuild this from the ground up, or when all you're doing is going in and creating an A/B test. As long as you decouple it enough, you can reuse pretty much anything you build. So our native integration, we followed the add to app method. It's in preview. This is that module template I talked about earlier. They don't talk about it in the Flutter executable. This is actually basically a simple project. It's a wrapper around the old method that they told you to do by hand. That creates a project with hidden .android and with .android and .ios folders that are designed to help make it easier to integrate. We at Capital One chose a tiered project structure, and this is why I explained always use packages. So we created that module, that single point of integration for all of our features that would be in Flutter. We had that app, which was our branch ATM Finder implementation, which was our standalone feature code. And then we had our plugin, which was our business logic components, and we had our package, which was our assets, that localization I mentioned. So this is how we tiered it. So the module only included the app. It only had a single dependency of that app path. That app path had two dependencies, both the block and the asset location, and that allowed us to do more with it. Apologies, the order's off on these animations. So the package allowed us to store the assets in a single place. We would reference it by the same package everywhere. We wouldn't accidentally not use package annotation, which was a big one. And then, of course, your display options when you go native in this module template is to use Flutter View Controller on iOS. iOS devs, catch that, your first thing. And then Flutter View or Flutter Fragment on Android. So your pub spec, you would have an app. This is the pub spec of your module. This is why I said my animations are a little off. So your app you would depend on that app standalone feature through a dependency, and that's all you'd include. That would then tier itself. It would get the plugins. It would get all the related dependencies for the app. And then in your main Dart for your module, you simply have your single point of integration where you would run the app with the widget for the Windows default route name. And you would pass that in through the native code. And then, of course, your case, and you would return the widget. This is all, this is pretty standard code. The difference here is that as you add more standalone features, so we did branch ATM Finder, but tomorrow we could do anything in our app. How do we go from A to B? And it's really simple. We create that, we start standalone. When we're ready to integrate, we add a new case statement here, and then through our Flutter View and our Flutter View controllers, we then reference that path or route, and that Flutter View will take on the widget that we needed to in that place. So a single point of integration from our native side is how this is done, and so we can script out features into a centralized location with repeatable and reusable code. I don't have that code. They won't let me give you that. Sorry. And unfortunately, that's all I got. Sorry. But thank you for your time. Thank you for coming.
All right, thank you so much, Pete. Questions for Peter?
Well, they're just links. I'm going to leave these up while we ask questions. If you have any.
Yeah, who's got a question?
Is this running live in Android or iOS right now? iOS?
It is running in Android and iOS. It's running in Android more than iOS. We had a problem with iOS. And it was a Capital One problem, so I can't go into it. It's got HIPAA rules and everything right now. The truth of the matter is the way that the Maps plugin works didn't work with our current build process. So we're still working through that. So it's not made it to production yet. It is running in our dev environments. It's running on my phone because where else do you test? But you test everything on my phone. That's how it works. As a dev, typically you are your first customer. So it's been I've run it on various versions of Android. We've ran into issues. There are some bugs here and there with add to app still because it is in development. where if you don't call your project app, it doesn't behave well. I'm submitting I'm submitting changes to the scripting to fix that. But it's working well once you get it working. Except for that minor issue we have with iOS, and it's really a capital problem because of how we structured our code base. Does that help? Thank you.
Are you developing more on Windows machines or Macs?
Are you developing more on Windows machines or Macs in-house?
I'm gonna flip that question around. Who here uses Windows to develop? Who here uses a Mac? I think you can. I'm not going to give away any capital and secrets. But if you're doing mobile development, you're probably doing it on a Mac because it gives you the most flexibility and it lets you target the most platforms. Having said that, I actually helped out with the Flutter camp that was here, that Nietzsche ran in New York City earlier. It was actually late last year, I think, right? And so I supported all three platforms, Linux, it also runs on Linux. Yeah, but no, I was there helping out as a TA, so I have programmed Flutter on Windows. I don't know why, I must have been sick that day. But it runs great, the scripting works well. The backslashes versus slashes gets a little hairy sometimes when you're trying to build scripting. But at the end of the day, Mac is probably what you're expecting.
In your experience, do you think Flutter is better suited for including a already working app, or if you had the opportunity to do the app from scratch, would you do it completely in Flutter?
So it's a great question. So for those for the recording, the question was new app in Flutter, or is it easier to do existing app plus Flutter?
Yep.
So the answer to that is clearly new app. Always do a new app. You're a dev. Every other dev was bad. You're better than every other dev. We all know it. We all know. The truth of the matter is that it's still not ready. That add to app, it is very kludgy. There's some things that don't quite work just yet because it's still in development. And we know how Google loves to say it's ready for production. It's RC 924. The truth of the matter is, if you're building a brand new app, I would start with Flutter if that's where you're leading. If you plan on going cross-platform at all, start with Flutter because it gets you there faster. And if you choose not to, if you're a native developer of one of the two platforms, whichever two platforms we're talking about, or cross-platform, it also runs web. So Dart at its core runs not just on mobile, but on web, on servers, in the cloud, on your phone, probably your PlayStation. I don't. Runs pretty much anywhere. So Dart is really the core of this, and Flutter is really just that mobile extension to it. It's something to keep in mind. So if you're building your business logic, there's no reason to not start with Dart. If you're building a mobile app, there's no reason to not at least consider starting with Flutter.
Performance-wise?
Performance-wise, I think that so. We're going to go deep on this one. Flutter's an engine. It's a game engine. It's a 2D engine. It's like building something for using Unity. It's building something using one of these things. It just makes it easier to do. Each pixel is drawn by hand through an SDK. It's not actually hitting the Android SDK. It's using its own widget kit. It's building pixel by pixel for you. So the trade-off you get there, they're still using Vulkan on Android, so they're still doing all the stuff that the Android SDK would do. They're just not doing it through the SDK. So you have the extra work that it has to do to run the engine, but it bypasses all the other stuff from the operating system. So that's your trade-off. Is it more performant? Probably when you're not in debug mode. I don't know that anyone's not in debug mode for the most part, though. Sorry. So the perform and I've had this question as well. My biggest question is, if I run my banking app for 5 minutes, and it takes up as much battery and memory as playing Candy Crush for 4 hours, is that really worth it? And so it's that trade-off. I've even asked that question of people who are very battery and performance conscious, and they've never looked at it that way. The expectation is that the trade, and from what I've gathered, that trade-off you're getting between switching from Android SDK and the kernel doing the SKIA to the Flutter engine doing the SKIA for you is where it gets your performance gain loss. It's minimal. It's basically what it comes down to. At least that's what I've experienced or heard. Does that help?
So how's the workflow between, what's the workflow like between Android and iOS developers? Has there been any conflicts in which Android developer prefer writing the dark code in one way, whereas and the iOS team wants it the other way?
The answer is code style dark question. Was there a problem with code style? Sorry, I'm just making sure everyone can hear. Code styles in Dart versus iOS developer versus Android. We have standards for all types of code, coding standards, formats, formatters. We typically try to follow whatever Google tells us to do. When it comes to code format, a couple of us have some OCD tendencies, so we're like, no, can't see that. We haven't, with the Dart code, we haven't really seen much. The tooling actually takes care of that because Visual Studio Code and Android Studio can both run the formatter on save. And Visual Studio Code, which is where Vim doesn't, but we just get someone who has Visual Studio Code to save it, and we're good. There's also the Dart format command line. So we haven't really ran into problems like that. The only thing I would say is that I'm a big fan of the trailing comma, so that everything lines up nicely, and not everyone is. So it makes wrapping things a little bit harder because you gotta go find the right place. But the trailing comma I'm a big fan of with Dart. I love that for those of you who know of it. Another question?
I guess when you started off trying to make cross-platform components, right? Have you ever considered other options such as, I don't know, React Native, something like that?
Yes. Question, did we consider any other cross-platform tooling and SDKs? Yes, React Native was actually huge on the list, and we've actually evaluated React Native. We've done Xamarin, as Michael said, and when I say we, Michael and I have done Xamarin. It's pretty much, a handful of people that looked at anything with the word Microsoft in front of it. So at the end of the day, yes, our initial app, our mobile app ages ago, our 3.0, or we call it 5, I think now, our 3.0 app was actually built using WorkLight with PhoneGap/Cordova. It was amazing, it was awesome. Crossplatform Technologies ruled. And then we moved native with 4.0. And we continued that strategy with 4.0, and then 5.0 we're like, yeah, let's go native. So yeah, we did look at React Native, we looked at Xamarin, we looked at obviously PhoneGap and Cordova again. Not that we would ever, I can't make any claims one way or the other about where we're headed. But what got us about Flutter specifically is the fact that the bridging, because it's done through an engine, through a J9, through, it's a mem-map. It's the bridging and moving memory from within Flutter back into your platform wasn't actually moving memory, it was just sharing the existing location space. And that's where it totally wins out over React Native, over Xamarin, where it's doing all of its code in C# and then it's calling those APIs through the SDK. Because it's mem mapping back to native, you get rid of that packaging, that double memory requirement of needing twice as much space. And so we did look at it. That's Flutter's more performant accordingly, because anytime you jump over that bridge, it allowed us to do things like build that native stack. In addition, with React Native, we had to build 2 different trees to keep track of them, one on the React side and one on the native side. And if you're an iOS developer?
No.
No.
That's
So
the thing.
the React Native story is better on the iOS side than it is on Android because it was built for iOS. I'm just asking.
Yes.
So for those of you who haven't seen or looked at it, it was built with iOS in mind, and then they're like, oh, and Android too, right?
I still don't think they care about Android.
Someone here, I care.
No, I mean React Native.
Oh, yeah. Well, I mean, we're only half the phones in the world, at least. I don't know how much time I have left for questions. Are we?
I would say one more question. Yeah, that's fine.
One more question.
Yeah. Anybody?
In the back there.
Back part.
Hi, so I was wondering, what was the process for you to migrate to Android X like?
The process of migrating to Android X. Great question. Aside from crying and getting some alcohol, no. The truth is, the Genify stuff that they've added, the ability to do it through some Gradle properties helped out. We ran into problems with data binding, so we used data binding as well, and boy, was that a problem. It was a huge problem actually, because the data binding would change the imports, but the data binding generates the code using fully qualified names, so it's still pointing to the old stuff. And then even better, the compile tools on Android Studio, the command line Gradle, everything stops at 50 errors, and we had just by changing to using Android X and setting up the Gradle properties to do that, we had something like 1,200 errors, and trying to squash bugs and errors 50 at a time. Everyone here's trying to do it. You're never going to get them. So we had to go. Stack Overflow is your friend. There's a command. Someone wrote it. It might even be you. Who knows? There's a command out there that tells you how to change that number from 50 to like 10,000. Thankfully, we didn't need more than 10,000. We could have done 2,000. But once we had the list of errors, it helped me find out and pinpoint some of these things. Like, oh, if I just change this one include, everything works. You know, I get rid of half of them. I moved. It's those last 5 or 6 that became a problem. And then even then, once it compiled, just because it compiled doesn't mean it works. And that's where we found our data binding problem. Our menu used data binding, and when I tried to open our settings menu to go in and turn on fingerprint, the app would crash every time. And I found out it's because we used data binding, and that the actual binding adapter was built by the system, was generated. That import was generated using the correct import, so it was Genify, but not the fully qualified name in the actual adapters list. So it added the first adapter was the default, and it used the com.android space, and not the Android X. So my solution to that was to overwrite that in the app code. So create the package name, write the thing, and point it out. That not ideal. I was just trying to get it done. It's probably why it's not in production. But the process took, I would say, once I really got into, all right, well, let me solve this. It took maybe 3 to 4 hours with these hacks. And as Android X is great, move early, move quick, but it did bring up the never treat anything like it's never going to change. So obviously, as much as you can abstract out and save yourself from these things, try and create single points of integration for things like that. Well, thank you all.
Thank you.